Video 3, 2.8, 2.9, and 2.10, implementing a test program, the Java API, and object references. So you're going to write some sort of a test or main program to make sure that any classes and methods that you wrote actually work and do what they're supposed to do, and you can make sure that they're running correctly. Now on the AP exam, you won't actually write a main method. You're just going to write classes and objects and have to sort of use them without really using, you have to create them without sort of making them run. But for the practice, and so you know what to do, we're going to write lots and lots of main methods, tester programs, and we're actually going to use what we write. So the purpose of a test program is to verify that one or more methods have been implemented correctly. A test program calls methods and then checks that they return expected results. So page 47 in the book. So it's really important that you actually generate expected results. That means you go in by hand and you do them yourself. So a test program is going to perform the following steps. You're going to provide a tester class, a main method. Inside the main method, construct one or more objects, apply methods, display the results, and step 6, the very important part, is to display the values you expect to get. So you're going to have to calculate that by hand, and that way you can check and see if your program is working correctly. Okay, so we've got a tutorial. We got tutorial 2.8 that you would hopefully write and run. So tutorial 2_8, which is moveTester.java, and it does a few things. So we create a rectangle box equals new rectangle 5, 10, 20, 30. Then I'm going to use the mutator method translate. I'm going to move the rectangle 15 to 25. So print information about the moved rectangle. So I'm going to print just to the screen for sort of readability, x:, and then print box.get with the return method, accessor method getx, which gives me my new x value, and then print out what I expected to be as 20 because I translated it 15. I added 15 to the x value. The x value is 5. So I expect it to be 20. Then we see what it actually is going to run. Now, so we'll go look at that in a second. The very first line, if you notice, in moveTester, all right, the very first line up here says import. This is a little bizarre. Import java.awt.rectangle. Okay, this is an import. You need to import the rectangle class from a package, the AWT or Abstract Windowing Toolkit package. It belongs in there, so it's a standard library. It's already been written. There's a few things, print, system out, that kind of thing, inst doubles, that the compiler and the computer always know how to do. However, if you want to use some more obscure pre-written library methods and classes and functions, you have to go ahead and go tell the computer where in the Java program they actually reside. So in Java awt.rectangle, then it will get all of my rectangle methods and classes, and it knows where to go find it. So when I write translate, it actually goes in and goes, I know where translate is. I can go find it and then access those instructions. So that is actually done outside of your tester class. So outside of your public class moveTester, you're going to import java.awt.rectangle. And then you write your test class, which is going to, in this case, test that the translate method works as intended by creating a rectangle and then actually moving it. So public class moveTester, open a curly brace, public static void main. So void means no return. We'll get into what the rest of it means later, but main, this is where my program again is always going to start. I have an explicit parameter for arguments, but there's nothing there. And then the block, which is actually my main statement right here. So this is where the computer starts. So first instruction in main is to construct a new rectangle. So the new operator, we're going to save it as an object reference called box. Okay, this is a comment. Instructions for you for readability. They don't actually get read by the computer. They get skipped. So move the rectangle. Call the translate method. So my object name, method name, explicit parameters. So implicit parameter here, explicit parameters here. Translate the box 15 units in the positive x direction and 25 units in the positive y. So print out again for readability x equals, and then get, this is another method, this is an accessor method, something it knows how to do, no parameters, get my x value and report it to me. In this case I don't save it, I'm just going to print it, and then print, we expect it to be 20 because again, I started out here 5 plus 15 equals 20. This is the stuff you're doing by hand. So the computer should print out 20. And then we do the same thing for the y. Get the y value. It started out as 10. 10 plus 25. We would expect it to say 35. And then when we go ahead and run the program to see if it generates the results we intended. So go in, tell Bluetooth to go into void main, don't give it any argument parameters. Our x value that the computer gets is 20, and then it prints the expected that we did. Then it goes and actually gets the y value, and then our expected result is 35. So it does match up, it's working as intended. Now if you notice in here, I've got a print command here and a print line command here. Remember, print means print something, and then the cursor sort of sits right here and blinks, and the next print line command starts there. So it says print x, print box get x, and then when you get done printing box get x, move to a new line. So that's why it formats it in the method that it does. So there's a tester program. Very important to use those to generate those expected results in advance, and then see if your program does them correctly. If we just printed get x, but we didn't know what x was supposed to be, and it printed 3. Oh, okay, so it prints something, right? But if we don't know what to look for, we're not going to know if it's doing something wrong. All right, 2.9, the API documentation. Classes and methods of the Java library. So this rectangle class, we didn't write translate, we didn't write the constructor for the rectangle. But if we are interested in how they work or why they work or what they do, we can go to the API, the Application Programming Interface, and you just go to the website and look it up. So I have it up here, docs.oracle.com, Java SE 7 Docs API. And this is what you get. So the Java Platform Standard Edition 7 API specification. All packages over here. So we were just messing with AWT, so it'll shorten it up. All classes. And these are alphabetical order. So we could scroll all the way down here to rectangle. And this is what we were just messing with. So it's under Java, Lang, Object, AWT, Geom, Rectangular Shape, Rectangle 2D. Finally get to the package java.awt.rectangle. And direct subclasses has apparently default caret is a subclass, which we'll get into later. So all these things you can scroll down and find information about rectangles in the rectangle class. That's an integer height, an integer width, an integer x, an integer y. Information about the y coordinate of the upper left corner of the rectangle. Okay, constructor, rectangle with nothing. Construct a new rectangle is 0, 0, and nothing. I have one parameter. I can do a dimension parameter, or I can do a rectangle with just an int width and an int height. So obviously then there's no x and y parameter, so the upper corner defaults to being 0. This is the one we've used, a rectangle with 2 parameters, all right, or 4 parameters, and an x and a y. Get width, get height. So if you click on it, it's going to jump you down to a little expanded one. Constructs a new rectangle whose upper left corner specified the parameters. Just a little more information. And you can find, so we did that get x. So here's our method detail, get x. And here's what it looks like inside of the rectangle class. So it's public. Its type is a double, so it's a return type, because if it wasn't a return type, it would say void. Its name is getX, no explicit parameters, empty parentheses. And what does it do? It returns the x coordinate of the bounding rectangle to double precision, so floating point precision, as specified by getX in the class rectangular shape. So this is how your methods work, and this is where you would find any and all information about everything that, in this case, the rectangle class knows how to do. All right, 2.10, object references. All right, so we've dealt with objects a lot. We don't really know exactly what it does. So in Java, a variable whose type is a class doesn't actually store that information. Remember, primitive types, if I say int x equals 10, the computer says variable memory space for x, actually go put 10 in there. It's there, it doesn't hold an object, it actually holds a number. But a variable whose type is a class does not actually hold the object, it holds the memory location of where the object actually is. Okay, so technically your variable is actually what's called an object reference to refer or point to the location where the object actually is. Class name, rectangle, variable name, object name, box, new operator. What am I making a new? I'm making a new rectangle. And let's go for the default one. So this is upper corner 0, 0, x equals 0, and our width equals 0, and height equals 0. Okay? So when the computer goes off and makes the box, it doesn't actually put all the information from a rectangle, all the methods, all the data, everything, over in box. What it actually does is it goes over in your memory, sort of allocates a space. It knows the type, so this is a type rectangle. This is a better picture than I'm drawing, is on page 53, but it has some data. It has x, y, width, and height. In our case, those values are currently 0, 0, 0, and 0. But box doesn't actually have all of that into it. That's off in who knows where in the computer RAM. Box just stores the address to go find it. Right. This is useful, but also can lead to some mistakes. Okay, so very important. Remember, an object variable does not contain the object, it refers to the object. New object, type rectangle, box 2. I'm going to make it equal my box. Now, I haven't made two boxes. I've merely copied my address. So I have box. I now have box 2, which is just an object reference in memory when we made them equal to each other. So now I have one box in the computer memory with two names, or actually one rectangle object in the computer somewhere in the memory, and two different names for it, two different things that know how to go find that specific one, which can be a problem. There's really no reason to ever do that. Remember, numbers, primitive types. If I did these statements, the values are actually stored in there. So the computer goes off and makes variable x and variable y. At the very beginning, x actually has the number 13 stored into it. Y equals 13. Or sorry, y equals x. So now y equals 13. I change x to 12. Now x equals 12, but these are independent of each other, so y is still 13. I haven't changed anything. All right, if I try to do that with an object reference, if I do this, I'm going to have a problem. Because it's not going to do what you might be trying to do here. This is a logic error, not a syntax error. The computer will happily do this for you. But what, if I was to see somebody doing this, you would assume, oh, they're trying to make two different boxes, and then they're trying to move one of them. So the intent would sort of be, at position 20, at 5 and 10, I have one box, and then I'm trying to sort of overlay the second box right there as well. And then in line 3, I'm going to leave my first box and move my second box. That would sort of be the understood intent. However, I made box 1 point to my rectangle that I actually made, because I only made, if you see here, I made 2 objects, but I only made I made 2 object variables, but I only made one new command. So I only actually made 1 new rectangle, but I've got 2 things that point to it. So when I go in and change box 2 and I call box 2 to translate, this really isn't true. What has actually happened is I have 1 box with 2 names. So I call box 2 to translate, and what happens? I translate box 2, but that happens to be box 1. I only actually happen to have 1 box. So instead of starting with 2 boxes and moving 1, I have 1 box with 2 names and I move it. So be very careful. Objects, variables, are references to where that object is. If I want to make 2 new rectangles, I'm going to have 2 new rectangle commands. I only have 1 new command. That's going to be sort of a hint that you have a problem. Alright? The reason sort of for this is that numbers, integers, and even doubles are very small. They don't take up a whole lot of space. Whereas objects, the objects we haven't, classes we've been dealing with, the objects we've been dealing with haven't been particularly large, although these things can get quite massive. So to sort of jump them around in the memory is tricky. So the computer just allocates 1 spot for them. They're sort of static. They stay there. And then I can manipulate references to them much quicker because it's a very small piece of memory to just have an allocation for an address rather than moving the entire thing itself.